Good day friends, welcome to my channel lecture series on power electronics. In this lecture, we will be discussing about the constructional details of a DC generator. Before we understand the constructional details of a DC generator, it is very important to know the basic concept, how magnetism is obtained from electricity. To understand this, we can just have a look at this image where there is a conducting material on which a coil is wound and a current is passed through this. When a current is passed through this coil, after some time, this conducting material would have gained magnetism. This was found out by Hans Christian Ørsted in the year 1820. This groundbreaking discovery was the first to link electricity and magnetism, demonstrating the magnetic effect of electric current. A magnet has got two poles, north and the south pole, and in a magnet there are some invisible lines which are shown indicated here. These lines are called as the magnetic lines of force or flux lines. These lines are invisible in nature and they start from the north pole, go into the south pole, and these lines are parallel to each other. When the magnetic lines are present just near the poles, the strength of the magnetic lines is more. That is, more number of lines come out of the north pole, and as we go away, the strength of the magnetic field will be reduced. So these lines are called as flux lines. 10 power 8 lines of magnetic flux is given as 1 Weber, which is the unit for the magnetic field. We have seen that magnetism can be obtained when a current is passed through a coil wound on a conducting material. So this was found out by Ørsted, but Faraday found out that electricity can be obtained from magnetism as well. That is the reverse effect of magnetism being obtained from electricity. When a coil is wound over a magnet, and if there is a change in the magnetic flux by either moving the magnet or the coil, the current flows through the coil if the circuit is closed. This shows that electricity can be obtained from magnetism. So magnetism produces electricity. This was found out by Michael Faraday in the year 1830, that a changing magnetic field can induce an electric current. The fact that electricity can be produced from magnetism forms the basis of a DC generator. So this is the generator principle where mechanical energy is converted into electrical energy. Here, if the magnet or the coil, if any one is moved, then the flux linked with the magnet and the coil changes, which results in the production of the electric current if the circuit is closed. If the conducting material is wound in this fashion, instead of being a straight bar, if it is made in this fashion, and if electrical energy, that is a current, is passed through this conducting material, we can know that a magnetism is produced here as shown in this picture. So when electrical energy is passed through the conducting material, after some time one would become a north pole and this side would become a south pole, and there will be magnetic lines of forces existing here. The magnetic lines of force will start from the north pole, will go through this material and reach the south pole. The nearest ends of the poles, the strength of the magnetic field will be very high. A simple DC generator has the following basic requirements: a steady magnetic field, a conductor or a coil capable of carrying current, and an arrangement to move either the conductor or the magnet. The principle of a generator can be understood easily from this picture. So that is a conducting material and it has become a magnet on passing a current through it. For the purpose of clarity, the coil which is used for making this conducting material as a magnet is not shown, and the magnetic lines of force are also not shown. Between the north and the south pole, there will be magnetic lines of force, and the coil is placed in the center and it is made to rotate using a prime mover. A prime mover is a mechanical device which can be a wind turbine, windmill, turbine, or any source that can give a mechanical input to the armature. So when this coil is rotated in a magnetic field, there will be change in the magnetic lines of force and that will cause a current to flow in the external circuit. So this is the principle of a generator where there is a magnetic field, there is a coil and there is a prime mover which is capable of giving a mechanical input to the machine. A practical DC machine would look like this. A DC generator or a DC motor both have the similar construction. Here we can see that there is a field winding and when a current is passed through the field winding, a magnet will be produced over here. And this is the coil which is called as the armature which is placed in the center. And there is a part called as a commutator which is used for taking the power output, that is the voltage generated in the generator will be taken out from the commutator. Actually the DC machine means it can be a motor or a generator. If it is a motor, we will give a input to the motor coil and it would start rotating in a magnetic field. But if it is a generator, we give a mechanical input and it would generate a voltage which will be taken out from the commutator. The essential parts of a DC machine are the magnetic frame or yoke, which is the outermost frame, pole cores and pole shoes, which form the magnetic field. Field coils are the ones which are making the magnet, armature core on which the winding is made, that is the armature winding, and we have the commutator and the carbon brushes. This is the magnetic frame or also called as yoke. This is meant for two purposes. One is to give complete protection to the machine as well as to form a path for the magnetic flux. This is a pole core. It's a solid pole core and this is a pole shoe. It can be either a solid one or a laminated pole core. Means it is not a single piece. Instead, a similar sized plates are used and they are all stuck together. That is called as laminated pole core, onto which a winding is normally made. This is a magnetic coil which is pre-wound and it is fixed onto the pole core. This is the armature core. This is also not a solid material. It is made up of a number of structures of this nature and they are all attached together to form a complete core. And in the slots, that is the gaps shown here are called the slots. Onto the slots, winding will be made. This is the armature winding which is inserted in the slots of the armature core and this end is called as the commutator. The ends of the winding enter into the part called as commutator. This part is the commutator and the ends of the armature windings are connected to the commutator. Brushes will be kept over this commutator. This is the carbon brush which is placed over the commutator for the external connection. This image shows the constructional details of a simple 4-pole DC machine. Here we can see that there are 4 poles and we can see this armature with the slots on which windings are made. The 4 black color small boxes are the brushes. The commutator are shown as the ring here and from the brushes the external connection is taken to the terminal box. The representation of a DC generator is shown here. The magnetic field is represented by a coil and the armature is represented by a circle. A generator is marked as G. If it is motor, it is marked as M. These two small square boxes are called the brushes. This being a generator, from the armature, the current comes out. So the arrow points out, and this current is marked as IA to indicate that this is the armature current. And when the current is coming out, it splits into two parts. One goes to the field and one goes to the line. So here the armature current is the sum of field current and the line current. The EMF generated by a DC generator is given by this formula. Eg is the generated EMF, and that depends on the flux phi, which is represented as phi. Z is the number of conductors in the armature winding. N is the speed of the rotor, and P is the number of poles. A is the number of parallel paths. So if the generated EMF is to be changed, we can change the flux. The number of conductors is fixed, and normally the speed of the prime mover will also be fixed. So by changing the value of this flux, we can change the EMF generated by a generator. In this lecture, the constructional details of a DC generator was discussed. Hope you have enjoyed learning about a DC generator. Thank you.